Welcome. In today's recording, I will go over one of the new features that is now available with the 7.2 release of the PowerHA SystemMirror software. This new release, it basically introduces what we call resource-optimized high availability. If we look at the capabilities that we had in pre-version 7 releases as far as the integrated DL part functionality, we did have integration with the modification of your processors from the free shared processor pool, and we did also have on-off capabilities for processors only. The 7.2 release, as far as elastic COD is concerned, also introduces integration with on-off memory, but the key feature that we're going to go through today is the integration with Power Enterprise pools. The 7.2 release does bring integration with the processor and memory mobile activations that you may have in your environments. This is an enterprise class feature, so it is only available with P7 Plus and in Power 8 with the E870 and E880 machines. But if you go ahead and enter the integrated panels, it looks very similar to the way that it did before. One of the things that you'll hit after you've defined your HMCs and you go into where you would append the values that you wanted for your processors, virtual processors, and memory values, you'll get prompted for your on-off COD agreement. By default, it's set to no. You do not have to answer yes, but once you proceed and you've said, hey, either reach in to on-off COD or let's go ahead and skip that because I anticipate on using the integration with enterprise pools, you'll get prompted for your actual counts, which you would like that partition to actually have active whenever your application workload is being hosted. So that may float back and forth between multiple machines, but within your cluster, you'll store the values that you actually want, and then HA will do a calculation on the activation of resources. So for the purposes of the demonstration, what I've got is I've got a 780 model on the left, Power 7 Plus machine, and then I've got an E880 on the right. Both of these guys are HMC managed. I do have a pair of HMCs in my configuration, so I've got my master and backup HMCs. You see them on the top. And then I've got an HA version 7.2 cluster in place, so set up across two partitions, one hosted on the left-hand side, one hosted on the right-hand side. I do have some shared volumes, and I am playing with current releases of AIX. So I'm playing with AIX 7.1 TL3 Service Pack 5. Version 7.2 of the cluster software will run with that particular level of AIX. It'll also play with AIX 7.1 TL4 and AIX 7.2. But for the purposes of the demonstration, I want it to be running on older code because more than likely clients may still be at those levels and not be playing with the latest bleeding edge code when it comes out. I do have mobile activations configured, and I've already set up the key file on the HMCs. So he is aware that I have an enterprise pool and I have 8 mobile activations for my processors, but I can swing at any time between the machines. I did go ahead and load up the specs in the animation. So these are both 32-way boxes, and each one has 28 configured processors. So the key part here is there's 4 inactive processors. The max that I could pull either on the left or on the right-hand side from the enterprise pool is 4. If I had a box that wasn't lit up all the way or was lit up with only minimal values, then maybe I could go ahead and draw in the entire 8 mobile cores. In my particular pool, I only have 2 participating members. Again, I could get an updated key file, introduce additional members, and then use those mobile cores distributed across however many machines participated in that pool. The nice thing with the 7.2 release of the PowerHA cluster software is that we can reach into the pool, acquire the resources automatically based on your settings, and then we will clean them up and release those resources automatically without you having to go into the HMC in the event that your workload swings from one machine to the other one, or you actually bring those partitions offline. So if we look at the actual COD capabilities for those boxes, I took screenshots of the HMCs, and I'm basically showing you that on these machines there's no trial COD. There's no on-off capabilities, whether it's for processors or memory. I'm only showing the screenshot for the processors. And then as far as the mobile activations, I do have that capability on the left and on the right. And I also have one currently active on the left-hand side and one active on the right-hand side. Those mobile cores that are currently activated are not part of my cluster configuration. So really out of my pool, I have 2 consumed, and I have a max of +3 that I can bring online, either on the left or on the right-hand side. If we now look at the bottom of my clustered LPARs, I set up my partition profiles to come up with minimal values. So simply on the power up of those LPARs, I'm running with half a processor, 2 virtual processors, and 2 gigs of memory. Now, as far as my application workload is concerned, in my cluster configuration, I've defined it so that when my resources actually come online and my application workload is started, my application has the requirements to be hosted with 3 active processors, a virtual processor count of 6, and I also went ahead and I incremented the memory up to 4 gigs from 2 gigs. I could have gone higher, but this is just a demo environment. So what I'll do next is I'll go over the actual demonstration. All right, so now that you've seen the logical view of the actual cluster configuration, let's go ahead and move on to the demo. So basically what I've got on my screen, on the bottom left is the reference diagram that I had pulled up earlier, showing my 2 physical footprints, the cluster, in blue for the actual cluster LPARs. You see what the machines are actually actively running with, and I'll show you that from the HMC side of the house in just a sec. And then in green, what you'll see the partition that's hosting the workload growing up to. Also on the screen at the very top, I've got the 2 machines that are being managed by the HMCs, so the 780 and the E880. You see how my available processing units, I've only got half a core available on the 780, and I've got 0 available on the E880. And then below that, on my other HMC screen, basically what I've got is I've got a view of the actual LPARs. So you see node 1 on the E880, he's actively running with half a processor, 2 gigs of memory. And then I see node 2 running on the E880, also half a processor, 2 gigs of memory. The current state is basically cluster services are down. So on the right hand side, I've got 2 PuTTY sessions open, one to node 1, one to node 2. And I've got a little wrapper script that probes the cluster manager daemon. Right now, both of the nodes are in ST init state, meaning that cluster services are not really hosting any resources. They're not up. The machine's simply powered up. On the bottom screen, I had already cached up my OS level command just to show you I am running AIX71TL3 Service Pack 5. I am playing with V7.2 code, and that code is slated to GA in December of 2015. So back on the top, one of the things I wanted to highlight here is I've already pre-configured keyless SSH over to the HMCs. So if I basically SSH out to either HMC2 or SSH1, doesn't matter which one, I basically don't get prompted for a password, which is one of the requirements that you need to pre-set up in order to enable the ROHA integration with the PowerHA software. So let me go into the actual screens, and if I come in and I go under Cluster Applications and Resources, when I proceed, the application server happens to be a resource. So when I go into the Configure User Application screen, you will see third option down, Resource Optimize High Availability. So basically this is the beefed up integrated DLPAR function that we had in previous releases. And what you'll see when you go in is you've got the screens where you can define the HMC or HMCs. You can add the definition. Mine already exist, so I'm just going to do a change show, and I'll show you that I've got HMC1 and HMC2 defined there. Actually, ATS HMC2 and ATS HMC4 is what they're called. But if I back up, the actual hardware provisioning is where you would actually see the values. But I've already shown you the 2 HMCs. Let me scroll back up here. And the other thing that I will show you is the actual HMC tunables. So there's different settings that you can play with as far as the HMC is concerned. Once you define the HMCs, you can tweak these guys. They are stored in the ODM. So you can see if I do an ODM get HCMP, the cluster actually knows about those HMCs. And you've got the values basically stored in the back end. And that's basically what you're doing when you're defining those integrated values for your application workload. The cluster knows about them. If it's got SSH connectivity to the HMCs, and when it's hosting the resources behind the scenes, it'll come in and manipulate the resources, and it'll reach into whatever pool it actually needs to. So let me back up from here and go into the actual ROHA screen. And if I go to chain show, since I've already predefined values for my app1 application controller, you'll see that I'll get prompted for the on-off agreement. I have no on-off capabilities or codes in my HMCs, so I'm going to leave that at the default of no. And what you see is my app controller that I had predefined before, but the screens look very similar to the way that they did before. There's nothing here that says reach into the enterprise pool. But you see I can specify values like the amount of memory to go ahead and append, the amount of processing units and virtual processor counts. That's not the actual target level. These are the values that it'll use when it performs its calculation to increment your LPARs up to. And you'll see how these values correlate a little bit later in the recording. As far as where it's stored, if you look at the actual application, if I could type, application controller definition, in the ODM, you basically see that the cluster knows about an application controller. Here's my start and stop logic, but beneath it, typically if you had no integrated DLPAR functions, these values would basically be 0. But there's my memory values, there's my processing units, and then the virtual processor count that is bound to that actual application controller. So let me go ahead and exit out of here. And one of the other things I wanted to show you. So basically what they've also done is with the new command line interface in version 7, they've introduced this new ROHA option. Now my cluster services were down as you saw earlier. If you invoke this operation, it'll basically SSH out to the HMCs and gather the information from the servers themselves. So you'll be able to see the enterprise pool information, you'll be able to see information about each of the physical footprints and their capabilities, and then also the ROHA values and the partition settings. So it should just take a couple seconds, and what you're seeing now is the actual tail end of the report. So the enterprise pool specific pieces, there's an ATS pool. It does know who the master and backup HMCs are. I have no enterprise pool memory in my environment, so hence why the demo is not actually covering that piece. And then as far as my enterprise pool, I have 8 available. As far as mobile cores, I have 8 total. Available only 6 because 1 is currently in use on the 780, and then 1 is currently also activated on the E880. Those are completely independent of my cluster configuration. So other teammates are using LPARs that have those mobile core activations. So what I'm going to do now is I will go ahead and I'll start up cluster services, and the things that you'll actually expect to see are you will see how the available processing units, we don't have enough, but you'll see that those values actually get incremented for just a second. And then what you'll see is my LPARs will grow to their target values that I had predetermined ahead of time. So we'll start up cluster services on node 1, and it should just take a minute. But as it's chugging along, what you want to pay attention to is not just the processing that's taking place up there, and I could actually just go to that node and leave the tail running on the bottom screen. But if you look on the top, you will see this value temporarily increment on the top for the available processing units. It's not chugging along and getting to that piece yet. It's basically the first node in the cluster, so it's having to orchestrate things under the covers, and it can make sure that he is the only active node and coordinate. But when you see it actually chugging along on the bottom right of the screen where it's actually processing and doing logic, you really could tail the HACMP that out file and take a look at the logs and see what it's doing. But you'll see it continue to chug along, but you'll see these available processing units go up And then in the process, in the middle HMC screen, what you'll also see is node 1 will be the only node in the cluster, but its processing units will go all the way up to 3. The memory will typically get acquired first, so you'll see that bump up to 4. But just as I am watching the processing on the bottom right, as soon as you start seeing the ROHA screens, now it's when he's actually reaching out to the HMC. And since he has no available processing units, he's going to see if there's an available enterprise pool. And within the enterprise pool, if he has the capability to do so, he will reach in there and acquire the additional resources. So it's still going through the processing on the back end. My screen got resized on the top, but you see that temporarily you see 2.5 processing units available. And what you'll see on the middle HMC screen is the 4 gigs of memory are there. What we should be seeing is the memory or the processing units go away on the top. They're back down to 0. And in the middle screen, you'll see the processing units get incremented to 3. And I apologize for the screen resizes. I was trying to keep everything nice and tidy for the recording. But now I'm actively running with a 1-node cluster. So if I do CL CMD CL state, you'll see node 1 is the only one that currently has cluster services up. I can come down here, go back to node 1. CL manager, 7.2 node 2. I'll start up cluster services on node 2. This one shouldn't take as long since he's not really hosting any resources or doing anything special. He's just going to be acting as a standby machine. His values are not going to get incremented because the actual resource group and the application controller are actually being hosted on node 1 right now. And you see that when I do a CLRG info, cluster services are up, or were up on it first. So RG1 app 1 is currently online on node 1. Node 2, the resource group is not being hosted there. It should be just about finished. And we'll invoke this operation as soon as I see it get to the prompt. Should be pretty quick. So CLCMD CL state, I see my current cluster manager daemon status is stable on both nodes. So now really node 2 is acting as a viable standby. The resource group is still being hosted on node 1. Just to show you how HA is actually going to manipulate the resources in the integrated screens, what I'll do now is I'll just do a simple resource group move operation. So I'll relocate my resource group from node 1, where he's currently sitting at, over to node 2, and we'll just do it via command line. If I could type again, app 1, and we'll specify the target node, node 2. I could have gone into the SMIDI panels, used the fast path. I could have used one of the older legacy commands to perform the move operation. I've kind of grown and gotten used to the new CL Manager utility. And you can see instead of having to write the word move or resource group, you've got a bunch of aliases that you can specify. But really, what it should be doing now is releasing gracefully on the source, and then acquiring on node 2. So in the middle HMC screen, you'll see the values basically get relocated. It should be releasing them back into the pool, but yet reacquiring them on the target side. And what you might also see is temporarily the resource is online on both. So I have the tail running just to show you that there's activity. We're not looking for anything specific there. But again, processing units are back down to 0. What we want to see is the memory get incremented up to 4 on node 2, the one hosting the actual resource group. It's already released the memory on node 1. We're back down to 2 over there. Notice that the processing units are back down to half. Might as well make these windows even bigger. And these pop-ups are kind of key, because what it did is it returned those mobile cores. Notice that you're getting pop-ups saying that those guys were reclaimed by the enterprise pool, so you're back compliant. And I have 2 HMC windows open, one to each one. One to ATS HMC 2 and one to ATS HMC 4. And notice that the values basically flipped. So it still went ahead and manipulated the enterprise pool. It released the resources back. And then it also went ahead and reacquired them on the target side. So it's doing all the cleanup on the back end. So notice that now my processing units are 3 on node 2. My memory is 4. and I can run the command with either cluster services up or cluster services down. What I'll basically show you is that those mobile activations, my pool no longer has 6 available, now it should have less. I've activated some on the actual target machine. So somebody's actually hosting the resources and using those active cores. So as soon as it returns back, we really care about the tail end portion of the report, which is what's going to be on the screen. So what you'll see is the enterprise pool listed, and you'll see the new values. So we're looking specifically here. So before I had 6 available, now I have 3. There is a total of 4 active on the E880, the 1 mobile core that was activated by one of my peers, and the 3 that I'm using for my cluster. Now, the nice thing here with the actual integration, it's not so fact that it's not so much the fact that it's doing the handshaking behind the scenes, but when I stop cluster services, so if I simply had a failure, or if I wanted to destage things, let's see, stop it cluster wide. So what we're doing now is basically saying, okay, the resource group had been relocated to node 2. I don't want it to fail back. Let's just bring everything, take everything away. And one of the things that I want to show you here, since nobody will be hosting the actual resources, my file system, my volume group is getting brought offline now. The IP alias that I had is also getting taken away. But it should be releasing the resources back into the enterprise pool. And what you care about is that pool being compliant. You don't want to have to go back into the HMC and do all that manual intervention. So as it's doing the processing and releasing the resources, not only is it bringing the resource group down, but you should see your memory go back. So that was first. We're back down to 2. Now my 3 processing units are still showing up there. The operation completed. So CLCMD, CL state. IMST init, and as I was moving up to the top right screen, what you also saw was the resize in the middle screen. I'm back to half a core. I am back to minimal available processing units. I'm still showing 3, but really I should be not compliant right now. What we should see within a couple seconds is that it'll stage the cleanup on the back end and spit out some pop-ups saying, hey, you're back to being compliant. So right now I have 3 unreturned mobile COD processors are still in use. You have 48 hours to basically get back into a compliant state. Right, that's the grace period that you have when you use Power Enterprise pools. But all unreturned mobile core COD resources have been reclaimed for the Power Enterprise pool, and the pool's back in compliance. And again, I'm seeing it twice because I have 2 windows to the HMCs actually open. So I am literally back to where I started, with half a processing unit available on the 780, 0 here. My LPARs are back to their original values. And if I look at the ROHA report, what you'll basically see is the fact that the enterprise pool should now have, again, a listing of 8 total in the pool. And beyond that, it's going to have 6 available mobile cores. The 3 that I was playing with are no longer being consumed. And the nice thing is, I don't have to go into the HMCs. I'm only doing that for the purposes of the demo. If I make this screen bigger, and let me bring this guy back over. What I want to show you here if I can get there. Here's the view that I wanted you to see. Enterprise pool processors. There's 8 and 6 available. Again, I'm back to 1 being consumed on either machine. I'm showing you the Power Enterprise pool screen from the HMC. If I click into the ATS pool, which is the pool shared between my 2 physical machines, again, this is the other view that you can see from the HMC and where you can manipulate the resources as well. But 6 available, 2 in use, 8. I'm seeing all that information from the cluster side of the house. So the integration is fairly painless to configure. I kind of went through the motions just to show you how easy it is. There's a nice value add from the perspective that on the standby node you can minimize your license counts, and HA can reach into the mobile core pool, activate the resources, release them, and handle all of that automatically for you. So that was the portion of the demo I guess I wanted you to see. In the next portion of the recording, or the next section, what I'll do is I'll explain in a little bit more detail the actual ROHA report. As you can see, it's rather lengthy, so I'll break it down for you, and I'll show you how the calculation is actually performed. Now I haven't seen the actual demonstration. For the last part of the recording, what I wanted to highlight is just kind of go back and show you what I had configured as far as my actual partitions and the actual application controller configuration within the cluster. So what you see on the top is the actual partition properties, what my partition profiles are actually set to whenever the partition actually comes online. So I wanted to show you the minimum and desired counts, and then show you what my max values were. For the actual processor counts. You can also see what my max values were for the virtual processor count. And on the bottom, you can see what the ROHA attributes were for the actual application controller. So rather than being the actual desired counts that I wanted to grow up to, it's basically the values that it's going to increment your partition minimum values to. So I'll show you how the calculation is performed in just a couple charts. So the ROHA report, I mentioned already that you can run it at any time, but it does dump a bunch of information. So what I also tried to do is break up the report so you can see the actual sections and what's covered in each one. The first one is the actual cluster tunables. You can see things like if you want HA to go ahead and process the resource groups, even if you don't have enough resources as far as what you had specified in the definitions. If you wanted to do things like modify the shared processor pool size, which is a new feature in the 7.2 release. That's also visible there. In my environment, I did happen to go ahead and turn that on. If you wanted to manipulate the release of the resources and make them actually get released in a synchronous fashion, which would actually take longer, the default is to process them in parallel. You can see that. And then the on-off agreement, if you've actually accepted it or not, that's also visible there. I opted not to use on-off resources because I don't have any available in my environment. Below, you can see how I also broke it up into two different colors, one for node 1, one for node 2. So the processing units and virtual processor counts are actually listed in the ROHA report. You can see them for node 1 and node 2. In blue, I wanted to show you that the application controller values, so the ROHA attributes, what you want the application to basically pull in whenever those resources are being hosted on whatever partition. Those are also displayed there. And then at the time that I captured the screenshot, you can see that my current processing unit values were actually higher on node 2 because my resource group was actually being hosted there. So again, you can see that at any time from the ROHA report. The report does actually continue. So if you looked at the latter portions of the report, I'm only showing you the portion for the E880. It was also visible for the 780 as well. But you can see things like the actual inactive processor count, how much memory is there, how many processors are actually configured. You can see things like the on-off COD, if the codes are in place or not without having to go into the HMC. And if this box actually participates in the enterprise pool. It should, being that I have it configured to be a member of that enterprise pool. And then at the tail end of the report, it does give you the detailed attributes for your enterprise pool. So this was the ATS pool that we used during the demonstration. And you see in red that I don't have any enterprise pool memory. So I opted not to actually use it in this demonstration. The enterprise pool processors, this was a pool of 8. Again, at the time that I captured the actual screenshot, it's shown that 7 were available because 1 was actually activated. And if you look at the bottom of the chart, you can see that it was activated on the E880 machine. As far as how the calculations actually performed, again, color-coded. On the left-hand side, I've got node 1. On the right-hand side, I've got node 2. You see my minimum values, but the middle row, the desired count, that's basically what my partitions are set to come online with. As far as the actual application controller definition within the cluster, these are the values that I actually had configured. So I told it the optional amount of memory to append is 2 gigs. The same thing for the processing units and virtual processor counts. And the way that it's performing the calculation, it's taking the minimum values that I had configured or defined for my partitions, and it's going to increment whatever I had defined in the actual application controllers. And as far as the logic, first it'll pull from trial COD if it's available, then it'll reach into the enterprise pool, and then it'll pull from on-off if you've accepted the license and you actually have it available on the machine. So the flow is basically going to be boot up based on your partition profiles, then process the application, and if you have any actual application controller values based on what those values are and based on what you have available in the box, let's go ahead and increment those partitions and grow them to the desired counts on the bottom. Based on where that workload is being hosted, you see the attributes that you would actually be running with. And if you were to go ahead and run the ROHA report once again, you would basically see the enterprise pool counts would actually changed based on where the workload was being hosted. So that's all I had. Hopefully you found the video useful. If you have any questions, my email information is available. Thank you. Bye-bye.